Good morning, good afternoon, and good evening, everyone. Today I'm going to do a resistivity measurement. I am going to carefully measure this at approximately 100 feet deep, precisely at that specific point. Therefore, I'm going to need a space of 300 feet. Because I'm going to measure from 1 foot up to 100. These are the minimum equipment needed to perform a resistivity measurement. Measuring tape, always have two, either rods or pins. The resistivity equipment and the associated cables. These cables are made to measure up to 100 feet. Always establish your reference point or your central point. This is where I'm going to take all my measurements. With reference to where this stake is, that's where I'm going to do my measurements. If I'm going to do a 10-foot measurement, then I measure 5 feet this way and 5 feet that way. But this is my center. What is the common mistake you've seen when resistivity measurements are taken? The first pin is placed here, the following ones are placed, and then when the measurement is extended, they leave this pin fixed and move the others. That's a mistake. They're moving the center. If before my center was here and I start making the openings over there, then what happens is that I would be moving the center to another position. I'm measuring the resistivity of another layer, but in a different position. I'm not measuring the depth of the resistivity. If I move the center, I'm sabotaging the measurement. So always your reference point and your measurements are taken from a central point, meaning that the central rods for resistivity are separated based on this midpoint. If I'm going to measure at 20 feet, that means I have to measure 10 feet from here to there and 10 feet from here to there to make sure that I'm measuring at this point at the depth I'm evaluating. Okay guys, I wanted to mention this because it's one of the most common mistakes I see when measuring resistivity. Let's continue. Okay guys, since I'm taking the measurement by myself, I need to extend the measuring tape and the cable at the same time. I use this rod to secure my cable here. And I securely fasten the rods at my designated reference point, as I previously mentioned, so that I can effectively extend the measuring cable. Remember that each and every time you meticulously take a precise measurement, when you carefully distribute the rods, you must ensure proper placement. When you are working with these components, it is absolutely crucial that you apply water to the tips. Currently, I am utilizing them primarily as temporary anchor points to secure the setup. However, during the actual and final installation process of the rods or pins, it is imperative to add a sufficient amount of water, and preferably for optimal conductivity, and to further enhance the elimination of any potential contact error, you should use salt water. This step is vital to ensure a robust and reliable connection. Alright, with that important detail covered, let's proceed to set up the next cable in our sequence. Okay guys, I've already meticulously laid out the measuring tape and the necessary cables in both directions. Since this particular spot is my central reference point and my absolute maximum depth will be precisely 100 feet, I carefully measured a total of 150 feet from this exact location to that specific point over there, so that each individual pin, with the maximum achievable depth being exactly 100 feet, will be accurately spaced 100 feet apart from each other. I have 150 feet that way and 150 feet the other way. That would be my maximum depth. Connecting the equipment isn't complicated at all. Notice that all the terminals are labeled P1, P2, C1 and C2. Current 1, current 2, potential 1, potential 2. The cable reels are also labeled current 1, potential 1, current 2, potential 2. It's quite simple really. If I'm going to make a connection, the various cables also inherently possess their own distinct colors to effectively avoid any possible confusion. For instance, if I'm going to connect the current one, I will specifically use the terminal that is clearly marked with the black color, and then I will come over here to the current one connection point, which is precisely this particular point right here. I'm going to connect to P1, which is potential 1. I will use the appropriate cable with the corresponding color, specifically red to red, and here I will carefully connect it where it clearly indicates P1. Now I'm going to connect C2, which would be current 2. The current is always injected at the ends of the bars, and the potential is measured at the central bars. Since there are 4 bars, because that's the proper method, current 2 with current 2, and I'm missing potential 2. With potential 2. Now I have everything connected. I just need to distribute the bars and start taking the measurements. That's all we have to do. Okay guys, normally we're always told to take this type of measurement or record this type of measurement at 0.5, 1 foot, 2.5 feet, 5 feet, 7.5 feet, 10 feet, 15 feet, 20 feet, 30 feet, 50 feet, up to 100 feet. But in this particular case, they're asking me to do it with these spacings: 0.66, 1 foot, 1.3, 2.3, 3.3, and so on. This is because my company is using specialized mathematical simulation software. And well, orders are orders. Pedro, take those measurements under those criteria, and that's what I'm doing. So, for example, right now I'm going to take the measurement at 6.6 feet. So, since I'm here, this is my midpoint where this flag is. I already know it's 6.6. I have to divide it by 2, which gives me 3.3 feet. So here I have 3 feet, 3.3. Here I have the bar because it's the midpoint. And from that flag, from this flag or this midpoint, I also have to measure 3.3 to complete the 6.6 feet of separation from this bar to the other center bar. But then the next bar from here to there should be 6.6 feet. So if I add 3.3 feet plus 6.6, that means I have to place the next bar at 9.9 feet. And then I would have the depth that they're asking for. How should we take the measurement? Please pay attention. Normally, we will always press the low button. Here you see the low and high buttons. We have a multiplier and the dial. So I press the low button. Notice that the needle activates. And I start to move the multiplier scale from higher to lower. I lower it, see that it doesn't react, lower it, see that it doesn't react, lower it, see that it doesn't react, lower it, and there it reacted on the 10 scale. It almost reaches the center, so now I start to move the dial until I center it on the arrow that's on the display. There I have it almost centered, and after I have it almost centered, I press the high position for greater sensitivity. So right now I'm at 1, and here on the multiplier I have it at 10. 10 times 1 gives me 11. So I then proceed to go to my digital tablet where I am meticulously recording all of my important data. So on the C.6 scale, I will carefully enter that my measured resistance value is precisely 11. Fortunately, I can already clearly see what precise averages I'm currently getting. But when I go to my comprehensive table, I can also easily observe how my visual graph is gradually taking shape and developing. I still need to finish all these measurements. That's why you see this down here, but it's because I'm recording in such a way that I can see both the resistivity, the average resistivity, and the average resistivity per layer. So basically, that's how the measurements should be done.